We're now going to consider yet another probability question. Suppose we have 2 dice which are rolled. Obviously, the score on each die will be recorded, and the score on each die can be a 1, 2, 3, 4, 5, or 6. Now, I will be interested in computing the probabilities of particular events. Now, there are various ways of working this thing out, but for this purpose, I'm going to consider constructing the actual sample space. So we can visualize all the possible outcomes that we could get. So consider, first of all, die 1. Obviously, the score can be a 1, 2, 3, 4, 5, or 6. And similarly for die 2, we can also get a score of 1, 2, 3, 4, 5, and 6. So this is our die 2. So these crosses here denote all the possible outcomes that we can have when I roll 2 dice simultaneously. So clearly, as there are 6 outcomes for each die, we will have 6 times 6, namely 36 outcomes. And so this sample space illustrates all of these. So clearly there is no outcome which is not covered by this sample space. Right, now let's consider some particular events that I might be interested in. So firstly, what is the probability that I get at least 1, 6 in my 2 die? Okay, well, it could be any of the following. There has to be either a 6 on die 1 or die 2, or possibly both. So I get a 6 on die 1 in all of these 6 outcomes here. When do I get a 6 on die 2? Well, it's all of these outcomes here. And clearly we can see that there is the intersection here where I get a 6 on both occasions. But remember, the event I'm looking for, it's at least 1 6, so that means 1 or 2 6s. So we can just basically count how many outcomes there are in this particular event, and we can see that there are a total of 11. We know that there are 36 outcomes in total, so remember that the probability of any event from your subject guide is the total number of outcomes corresponding to the event you're interested in, divided by the total number of, in this case, equally likely outcomes. So this probability is simply going to be, there's 11 outcomes that are in this event over 36 possible outcomes. So nice and straightforward there. Right, let's consider a second one. The probability that the sum of the scores on both dies is exactly, let's say, 4. So which outcomes will this entail? Well, I could get a 1 on the first die, which means I would need to get a 3 on the second. So this observation here, the sum of those two values, 1 and 3, gives me 4. If I had a 2 on each die, 2 plus 2 gives me 4, and similarly a 3 on the first die and a 1 on the second. Notice that these are the only possible outcomes such that the sum of the 2 scores is equal to 4. And so what does this probability come to? Well, this is just going to be 3 over 36, which I can also write as 1 over 12. Does it matter if you would give your answer as 3 over 36 or 1 over 12? Well, no, because they are equivalent, but usually with fractions, if you can reduce them, do so. Right, well, let's consider one final event, something slightly more demanding. So part 3. I want the probability that the sum of the 2 scores is strictly less than 9. So which events will these be? Well, I can think of doing this, can approach it in one of 2 ways. I can either work out the probability that the sum is strictly less than 9, or I know that this thing will be equal to 1 minus the probability that the sum is greater than or equal to 9. Okay, because remember, the probability of A is always equal to 1 minus the probability of the complement of A. So, which events do we have here? Well, let's first of all think of the sum being strictly less than 9. Let's pick another colour. Let's go for pink. Right, so which outcomes in this sample space correspond to the event that the sum is strictly less than 9? Well, we can see it's going to be all of these here. So everything within that pink boundary, we can see that the score is going to be strictly less than 9. Also, thinking of it the other way round, which of the outcomes such that the sum is greater than or equal to 9, well, it's going to be everything not bounded by that pink line, so namely it's going to be these ones here. So you can work out this probability either way. You'll still get the same answer by looking at directly those whose sum is strictly less than 9, count up the number of outcomes within that pink boundary, and you should come up with a total of 26. And remember, there are 36 outcomes in total, so this can be written as 13 over 18. They are equivalent. Or if I was working out using the complement technique as 1 minus the probability that the sum is greater than or equal to 9, then this will just be 1 minus, well, how many outcomes are there where the sum is greater than or equal to 9? Well, those are all of the outcomes within the yellow boundary. Count them up and you should come up with a total of 10. So 1 minus 10 over 36, which gives me, obviously, 26 over 36, or again 13 over 18. So just to summarise what we've looked at here, it's just a very simple probability problem, something which typically might come up in section A of the exam. We are interested in finding the probabilities of particular events of interest. In this particular case, where I have 2 dice which are rolled, it's been an easy way to actually construct the entire sample space and then from there work out which particular outcomes fulfill your particular event.